Good morning, everyone. Nice and early on a beautiful spring June morning, Sunday morning, as I record this. Pretty straightforward topic this week in the world of data science, and that is two subdomains of business intelligence: data mining versus data analytics. A lot of this stuff very similar, but human beings, we like to categorize and we like to label things. So, so here we do. We have a couple of categories and a couple of labels. There are differences, as you'll learn in coursework and perhaps in practice. I'm hoping that those of you that are in the data analysis world versus software development, whatever, will pitch in with your real world work experience this week, and not just what you've learned online, but you know if that's what you have to share, then that's fine too. Okay, so we will move on here. Data mining versus data analytics. Subtle difference. So we'll talk about what each one is. Mining is a metaphor, and I'm gonna use that metaphor um, and explain that further, or at least talk about it. And then we'll talk about data analytics. That you have a discussion question this week, and then I wanted to continue with the dissertation support. Um, Although there's no assignment for it, I've got a video I recorded last fall that that expands on last week's discussion question about a research question and problem and purpose statements. And this supplemental video is on methodologies, how you go about collecting and analyzing your data according to a set procedure, an accepted practice for conducting actual research. And then we will conclude, and between the two videos, uh, no more than an hour of watching online. Okay, so data mining. Here's the definition oh shoot, I I just I covered my words with my picture, didn't notice it. It's the practice of searching through large amounts of data to find useful patterns or trends. Searching through large amounts um, of computerized data. So there's the graphic there. That's the three wings of computer-based technology that help with data mining. Though it can be done manually, it helps to have AI algorithms that are starting to look through, massive volumes. Mostly, what AI seems to be the most AI research is heading towards is on natural language processing, image recognition, video processing, those sorts of things, to pull data out um, of unstructured data that would be very tedious to go through manually, like the Google Maps car driving around. Google Maps car sees all kinds of things that could be considered data. Uh, what is the most popular car um, by make and model in Cleveland, Ohio? Now, you could go to the DMV or um, car dealers or whatever, or you could look on Google. If Google Camera could analyze all that video data, it would actually see which make and model of cars are on the streets, parked on the streets, driving down the street, parked in driveways. So that's where AI lets it's going to let us comb through video like we've never or comb through data like we've never been able to do before. And then then you've got machine learning algorithms. I'm no expert at that, but I have done some played around with scikit-learn and classifying, making classifiers that can look at more structured data and can help make sense of large data that would be really tough to classify based on other. You can make a classification of data based um, on its characteristics, and then of course you got statistics, looking for things like correlations between variables, descriptive and inferential statistics. So those three together let you mine data. Now, where this metaphor comes from is, English, I believe, almost uh, um, with an eye towards American history, really, not just American, but in the mining process, someone in the mining industry will go out and it's just dirt. Uh, they're just going to where it looks geologically promising. So they've got a big pool of what could be considered data in the form of rocks and dirt out in nature. So mining operations always begin by prospecting or uh, looking through the various geological layers and formations for what are useful signs that there may be um, valuable, there may be value in there in the form of gold, silver, oil, lithium, you name it. They're out there looking for value in the geological substrate. Well, data mining is a lot like that. They're out there like back in the old west. The miner would take um, his pan, his metal pan, and and pull up some rocks and sand out of the stream bed because gold tended to wash down through creek beds, and they would start swirling around, and gold is heavier than sand. Valuable data starts to appear. Valuable metals can appear through different tests, and a pan test was a great way for prospecting for gold to see if there are any prospects. See, all these words relate. So if an area, a creek bed, or not even, they could mine through other just dry panning, they call it. But if it pans out, that's where you see that. I hope that pans out for you is an English colloquialism you'll hear, and it means if something shows promise or shows value. So if a mine pans out, industrial scale mining can begin, and it's similar with data mining. Um, when a data miner, data scientist goes in and starts using these techniques, um, then it gets to be where that data set can be turned over to the other part of our topic, which is data analytics. But so miners are looking for clustering pieces of, and this is all I posted resources, references, articles in the speaker notes of the slides. So make sure you check those out too. Very closely related, but they're looking for clustering pieces of data that kind of go together. Um, and are related to each other. Deviations, if something sticks out, that might be good, it might be bad, it might be the truly the gold. If you look at the way the data is laid out and there are anomalies, that might show some value. It could also show errors in the data though, so they got to look at it. Classification, that's one of the things machine learning is good at, is um, putting certain uh, putting certain types of data records in different bins according to a rule set. Like some of the examples you'll see out there, are spam filters are certainly, whether an email is spam or not. But then uh, you'll see a lot of classification um, work being done in like e-commerce websites, where they will classify you as a certain type of consumer, likely to buy an impulse buy. You buy a lot of gifts, you return things a lot. Facebook, of course, will have you classified as a young, tech savvy, millennial guitar player. So based on your search history, your likes, your tags, they you are classified in the whole data driven marketing world, and they get better and better at that. I've got colleagues and graduates from our coding boot camp at the University of Central Arkansas that work in data driven marketing, and it is scary the way they use data mining and classification, well, machine learning, really, particularly to classify you as an individual. You can avoid that by never logging into anything, and never tracking using cookies or any of that, but we all just use it. Oh yeah, correlation. Yeah, everybody, you're always looking for things that are related so that you can do regression testing and projections and those sort of things. So, and then, as opposed, again, make sure you look at the speaker notes. Data mining is kind of exploratory, whereas data analytics, I put in bold here. One of the definitions I found of data analytics. Actually, this is a definition of business analytics, but they're so close together. I liked this definition, and here's the article. It comes from one of the references in the speaker notes. But the main thing I wanted to is, it's everything, but it's looking through data to gain insight and drive business planning. So it's supporting decisions. It operationalizes the data into a more of a cycle, more of a science, as opposed to like an industrial operation versus walking through the woods looking for something, looking to discover something new. Data mining is a little more exploratory, and data analytics is a little more operational. So that's the gist of it. They're all very closely related, using a lot of the same, kind of analytical thought processes and data sources, and it can go from across the spectrum of structured data to unstructured large scale data. Like I said, I'm personally fascinated, interested um, in this, you know, big data, big video classification, real time. If you haven't seen it yet, watch. There's a public broadcasting system, a PBS special called Rise of the Drones. Um, I used it in an earlier lecture. I mentioned it in an earlier lecture. Rise of the Drones, and there's a drone in there that was experimental 4 or 5 years ago. I'm sure it's operational now, called Argus. Argus, and it used inexpensive cell phone videos to be able to take um, a city-sized eye in the sky, and it could classify everything down to a bird flying, person walking, car parking, just and then the petabyte a day of data that it generates between the video and the processed, unprocessed raw video and the processed data. That's just going to explode in the future, though. So there's a difference between data mining and data analytics, and that's what your discussion question is this week. But I want to make sure that you get it. So lots of examples out there. So hopefully you'll pull something in from your own experience. And if you do use something from the internet, and you cite a source, make sure you're actually reading and comprehending the article that you're reading. I'm trying to avoid the temptation of uh, you know citing something that looks like an academic work, but there's no real analysis behind it. So make sure you are uh, taking all that into account as we've discussed previously. Um, and an example of each. So try and find a cool example, a functional area, a domain where data mining and data analytics is being used in a BI framework, and provide that example to us. Practitioner is okay. We always want academic references if possible, but if what you can find is a case study from a practitioner source, that's fine too. So there's your discussion question this week. I look forward to that discussion. Um, and in conclusion, don't rely completely on the article posted in the syllabus and in the folder this week, because it is a focused example of a type of mining, educational data mining versus learning analytics. It's a similar comparison and contrast as the general, data mining and data analytics, but that article is specific to the educational domain, and it's important that you realize that all too often students will focus on an article and think it's the only thing written about a topic, and it's not. So, actually, whether you read and use that article or not doesn't matter to me, because it is just one subdomain. But make sure you check it out if necessary. But there's all kinds of articles out there on the library website and Google Scholar about this stuff. So yeah, they're both a subset of BI. But make sure you watch the research methodologies video. You, you guys are going to conduct a research project. In the discussion last week, I posted a few dissertations. Make sure you go back to last week's discussion and download even if I didn't provide it to you, make sure you download those dissertations and start collecting material, so that, and reading them. That's the other thing. The main thing is reading, scanning these things so that you start to see these discussions. Like the supplementary video I put out there was research methodology. My research was qualitative because I was kind of exploring a phenomenon where very little information existed. So make sure you're checking that out. Okay. Questions, comments, concerns, feel free to email me this week. And everybody have a great final week of spring, because I believe next weekend it will be Father's Day, by the way, when I record my next lecture. And I am a father. I have 3 children. But it'll also be summertime coming up here, I believe. The first day of summer is next weekend. Woo, summertime and the living is easy. Okay, guys, have a good week. Work hard, work smart, and I will see you online.